Good to have you once again. Here we are going to be looking at Iupac nomenclature of inorganic compounds. What are inorganic compounds? They are simply compounds that are manufactured in the laboratory from mineral elements. Of course, we have other compounds in chemistry which we are going to deal on maybe in later classes. Those compounds are the organic compounds. But based on this class, we are going to concentrate on how to name inorganic compound using the Iupac convention. Now, what then is Iupac? Iupac simply stands for International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. It is a set of conventions or rules that are used to name compounds or substances all over the world. It simply shows that if a compound is given a particular name or assigned a particular name here in Nigeria, the same compound is given the same name all over the world. This rule is very important in naming compound, most especially in chemistry, as it makes it easier for the study of the subject chemistry. Without these rules, it will be very difficult for us to name compound because it has to do with different rules in naming a particular compound, which is not generally acceptable. Now, based on that, we are going to look at how compounds are named in different areas. In this class, we are going to concentrate on naming of compounds that are made up of two elements, which is called binary compound. We also have compounds that are called polyatomic ions. And when we say polyatomic ions, we mean compounds that are made up of more than two elements, and one of the elements is usually oxygen. We are also going to look at naming of compounds that some of them are metals while the other is non-metal. And we also finalize by talking about compounds that are made up of non-metal. So let's talk about the first one, which has to do with binary compound. Now, what are binary compounds? We say binary compounds are compounds that are made up of two elements. How are binary compounds named? Binary compounds are named by giving the name of the metal first before the non-metal. That is, the metal is named before the non-metal. So let's take a look at examples of binary compound. Okay, so we have binary compounds. Examples, we have compounds like magnesium and oxygen. So magnesium and oxygen will simply give us a compound called magnesium oxide. So magnesium oxide. So here is indicating that the metal is named first before the non-metal. So we also have sodium and oxygen to give us sodium oxide. Sodium oxide. We also have aluminium oxide. So we have aluminium oxide as another example of a binary compound. Now, these cases are cases whereby we have a metal reacting with a non-metal to form a binary compound. When binary compounds are formed between a metal and a non-metal, we normally end the name with the suffix IDE. So binary compounds are named when both of them consist of metals and non-metals. We end their names using the suffix IDE. Okay, so now let's look at examples of other compounds that we can end the name with the suffix IDE. So we can have compounds like potassium chloride. Potassium chloride as what? KCl. Okay, so we can also have sodium hydroxide as NaOH. Okay, we can also have magnesium bromide. Okay, so we can have MgBrO2. Okay, so now based on this, we are able to show that when naming binary compounds, we end the name with the suffix IDE, just as we have chlorine becoming what? Chloride. Chlorine becoming chloride. Oxygen written as oxide. We have iodine written as iodide. We have sulfur written as sulfide. So we can have these cases and others as examples of compounds or examples of binary compounds where we end their name using the suffix IDE. Now let's take a look at other examples of binary compounds that are made up of two nonmetals. In that case, we calculate the oxidation state of the first element and we also end the name with the suffix IDE. So we have example, we have CO. So of course we say using the rules we talked about in trying to write the correct formula of a compound, we calculate the oxidation state of the first element and give the name of the compound. So we have CO is equal to 0. So we have C plus the oxidation state of oxygen, of course, is minus 2, except in peroxide. So we have C minus 2 is equal to 0. So C is equal to plus 2. So hence the name can be carbon 2 oxide with the 2 written in parentheses or in Roman numerals. We can also have another example as CO2 equal to 0. So we have C plus minus 2 multiplied by 2 is equal to 0. So we have C plus minus 4 is equal to 0. So C minus 4 is equal to 0. C therefore is equal to plus 4. So we can give the name as carbon 4 oxide. Okay, yes, so carbon 4 oxide is the name of the compound. Now we can also have another example like SO3 equal to 0. So S plus minus 2 times 3 equal to 0. S minus 6 equals 0. S is equal to plus 6. So the name of this compound is sulfur 6 oxide. Okay, so that is how binary compounds are named, ending their name with the suffix IDE. Wow, that is interesting. Now, having talked about that, let's talk about other complex compounds. Before you give the names of other complex compounds, that is, compound that has to do with what? More than 2 elements, you must calculate the oxidation state of the central element or the central atom. Now let's take a look at some examples of some compounds that fall under polyatomic ions. So we have polyatomic ions. Polyatomic ions. Of course, we say polyatomic ions are compounds that are made up of 3 elements and above, or more than 2 elements. And one of the elements is usually oxygen. So how do you name polyatomic ions? In naming polyatomic ions, you name the metal first, followed by the number of atoms in the oxygen before you name the central element. So now let's take a look at a common example of a polyatomic ion, just as we have here in K2CR2O7. Now we say the sum of oxidation state of elements in a compound is equal to 0. So if we have the oxidation state of potassium as +1 multiplied by 2 plus you make CrO, which is the central element, the subject of the formula, plus -2 times 7. Of course, we say the oxidation state of oxygen is usually -2, except in peroxide. So we can have +1 multiplied by 2 will give us +2 plus CrO2 plus bracket -14 equal to 0. So collecting like terms, we have CrO2 is equal to 0 plus 14 minus 2. So CrO2 is equal to plus 12. Therefore, CrO is equal to plus 12 divided by 2, which is plus 6. So we can simply give the name of this compound as potassium. That is, we name the metal first, potassium. We now go to the number of atoms that makes up the oxygen, which is 7. So potassium, and 7 is given the name hepta. So potassium, hepta, oxo. Then we have 2 atoms of chromium, so we call it dichromate. Then we end the name with 6. So potassium, hepta, oxo, dichromate 6. That is the name of the compound. That is very interesting. Let's look at another example of a compound that we can name, or another example of a polyatomic ion that we can name using this concept. So here we have a compound like CuSO4. CuSO4 equals to 0. Of course, the oxidation state of copper is +2 plus S. Sulfur here is the central element. Of course, we said in naming polyatomic ions, we make the central atom the subject of the formula, which reflects the name of the compound. Okay, plus we have -2 here multiplied by 4 equals to 0. So plus 2 here plus S plus minus give us -8 equals 0. So by the time we collect like terms, we have S is equal to 0 plus 8 minus 2. So S is equal to plus 6. So the name of the compound here can simply be called copper 2 tetra oxosulfate 6. Okay, copper 2 tetra oxosulfate 6. That is the name of the compound. With that, we have discussed about Iupac nomenclature of inorganic compound using this set of rules. We are going to end here in today's class. Hope to see you in our next class, where we are going to be talking about naming of ions and how to name acids.